Hi, students. How are you? This is Ms. Wachuku again. Today we're going to be talking about evidence of chemical changes. So if you look at your pictures on there, each one of those demonstrates some sort of evidence of chemical changes. Our learning goal for today is going to be investigate the evidence of chemical reactions that indicate that new substances with different properties are formed. So once again, how do we know that new substances have been formed? Our success criteria for today is one, we're going to describe the physical characteristics of a physical change. Number two, we're going to describe the characteristics of a chemical change. And number three, lastly, we're going to compare and contrast those in order to kind of see in different scenarios whether we had a physical or a chemical change. So starting off with chemical changes. A chemical reaction occurs when two or more molecules interact and the molecules change into a new substance. Bonds between atoms are broken and created to form new molecules. So here in this example, we have one molecule of CH4 with two molecules of O2, and that creates now new substances. Notice how the atoms have been rearranged, and now I have CO2, which I know is carbon dioxide, and we have two H2O, which is two molecules of H2O. So once again, a new substance is formed. Now, according to the law of conservation of mass, we still have the same number of atoms. So if I had one carbon here, I still have one carbon here. Four hydrogens here, I have 2 times 2 is 4, 4 hydrogens here. Lastly, 2 times 2 is 4 oxygens, and I still have 2 oxygens here, and then the 2 oxygens here, because 2 times 1 is 2. So you got to keep in mind the law of conservation of mass. You're going to see that in one of your worksheets. If the mass is the same, then that's how you know that you've also had a chemical reaction. Once again, even though you have new substances, the mass has to be exactly the same. And that's according to the law of conservation of mass. Physical changes. If we have a physical change, it just changes the form or appearance of a substance. We pretty much keep the same ingredients, but it just maybe changes form or appearance. It may look the same. So here, these are beaten eggs, but they are still eggs. Water, whether we boil it or freeze it or leave it at room temperature, once again, it just changed maybe form to a water vapor or it became a solid, but it's still water. Does not change substance into anything new. Once again, it remains the same. Examples are whipping eggs, boiling water, dissolving sugar, dicing vegetables. A lot of students get kind of confused with the dissolving of sugar because you can't see it anymore. It's dissolved in there. But once again, if we were to let the water evaporate, we would be getting that sugar salt back. Okay? So that is called, by the way, a mixture. Physical changes change the state of matter. They can change the color. They can change temperature, shape, or texture. When I mean by changing color, if you were to add food coloring to something, if I were to add food coloring to milk, it is still milk, even though it's green milk or blue milk. Adding food coloring is not a chemical change. That is just a physical change. It remains the same thing. Chemical changes are when two or more substances join to form new substances with new chemical properties. Examples: iron rusting, gas burning, eggs cooking, and bread rising. So here in this first picture, we have the iron that's rusting. Well, when we remove that rust, it is no longer iron. It's no longer has the same properties. For example, it's no longer going to be metallic looking and shiny. Now it changed color, right? The egg as well. Once again, it no longer has the same properties as the original egg. Or the dough, it no longer has the same properties, okay? By the way, a lot of these you can no longer go back to the originals. So if I make a cake and I combine oil, the flour, milk, I can no longer get those original properties back. or substances, sorry, back. For our students, remember that evidence of a chemical change, remember country girls like their phones. Country means color change. So if you have any sort of color change, like with the iron that rusts, that is color change. Girls is gas production. So if a gas is produced, if you see bubbles, if you hear fizzing. L is light, if you have a spark, if you have fire, if you have an explosion. Fireworks, that is a chemical change. Okay, so there was light produced. T, temperature change. So if it was an exothermic reaction, meaning it got hot. Endothermic is it got cold. There was some sort of temperature change. And lastly, precipitate, those solids that are formed sometimes at the bottom. Normally they tend to sink, precipitate. Unexpected color change are new molecules created in a chemical reaction that radiate light differently, producing new colors. So if you notice right here, this, the two liquids are clear, but when they mix, they form this yellow substance. Examples, fireworks, like I said, or leaves a change of color. Leaves that change color. That is also a chemical change. Unexpected temperature change. During chemical bonding, energy is released or absorbed, making their surroundings hotter or cooler. Some examples is adding baking soda to vinegar. That causes the temperature to decrease. And we went ahead and did that in class earlier this year. For this one, I would also think of, for example, the hand warmers. Whenever you go to a game, sometimes if it's cold outside, people use hand warmers. Once you break that little packet and you start mixing the chemicals in there, it produces heat. Body temperature increases to fight infections. Combustion or burning. A chemical reaction between substances, usually including oxygen, accompanied by giving off heat and or light. So if you have that production of light. This is a permanent change that cannot be undone. For example, when you burn wood, you can no longer get your original substance back. A candle burning or rusting. Once again, you cannot get the original substances back. Precipitate is formed when a solid suddenly appears in a solution and settles to the bottom, collects on another object, or makes the solution cloudy. Examples, milk souring or the bathtub rings. Bubbles form when gases produced in a chemical reaction are released. Examples are Alka-Seltzer. When you put in the Alka-Seltzer into the water, they tend to fizz and you see bubbles. Or bubbles released when vinegar and baking soda are combined. So really quickly comparing and contrasting the two. Physical change changes the form or the appearance. It does not make a new substance. Once again, you stay with the same substance. It just changes shape, size. For example, if you get a block of gold and you hammer it into a necklace or into earrings, you just change the shape and the size, but it is still gold. You can melt that gold and change the state of matter, so you can go from a solid to a liquid, but it's still gold. Boiling, melting, freezing anything, once again, you are still with the same substance. Now, chemical changes is when two or more substances combine to form a new substance. Now you end up, what you input is not what you get at the end, is not the output. You have a new substance with new properties. For example, burning, rusting, tarnishing. Once again, something new is formed, and that evidence is that country girls like their phones. Color change, gas production, production of light, temperature change, or phones precipitate, okay? So I'm going to go through a couple of examples here, and you're going to think to yourself, is it physical or chemical? So melting ice. Can you go back and get Can you go back and go make it a solid again? Yes. So once again, this water right here can turn back into this little block of ice just by simply freezing it. So this is a physical change. Burning wood in a campfire, physical or chemical? It is chemical because you can no longer get that wood back. Okay, plus you have production of light and heat. Tearing paper. If I tear some paper, it is still paper. Once again, it is still paper. You still have the same substance. Paper is paper, whether it's a big piece of paper or a small piece of paper, it's still paper. That's physical. Mixing two substances and a solid is formed at the bottom when you mix milk and vinegar. So once again, this would be a precipitate, and that new mixture, that's a new substance. Okay, so it's no longer milk and vinegar, it's a new substance, and that is precipitate, so it's a chemical reaction or change. Hammering gold until it becomes flat. So you have gold and you're hammering flat. Is it still gold? Yes, it's still gold, so that is just a physical change. Combining two substances and the temperature of the product increase 5 degrees. Like I said, those hand warmers. You mix the two chemicals in there and it produces heat, and production of heat is one evidence of a chemical reaction. A bicycle sits out in the rain for a year and rusts. So once again, now you had a color change because it's no longer shiny. It's no longer aluminum or whatever the bike was made out of. It's no longer shiny metal. It is now a new substance, which is that rust. So it was chemical, sorry guys. Cracking and egg. Doesn't say cooking, it says cracking. Is it still an egg? Yes, you still have the same substance. So it is a physical change. Combining two clear substances and the solution created is bright yellow. You have a color change. So clear, and now I have a yellow substance. That is a chemical change. When boiling water, the water turns into steam. So I have liquid water right here and I have water vapor, but ultimately it is still water. Okay, it just changed form from liquid to a gas, but it is still water. So physical. Adding an Alka-Seltzer to water and bubbles form. So this right here is a new substance. You actually form some carbon dioxide bubbles, and that is a chemical change, and an evidence is bubbles. Okay, gas production. Baking a cake. So when you bake a cake, you combine all of these ingredients, all these substances, and now you have, excuse me, and now you have a new substance, which is the cake. So once you bake it, it is now a new substance, and that is a chemical reaction. So once again, a check for understanding. Are you able to investigate how evidence of chemical reactions indicate that new substances with different properties are formed? Are we able to do that now? All right. Now, I'm going to kind of lead into one of your worksheets. It's going to ask you to kind of describe something, and I'm going to give you the example here of what you learned in 7th grade. Once again, this is review from 7th grade. Create one example of a physical change in the digestive system and one example of a chemical change. So once again, in the digestive system here, we have two types of changes. One is physical and one is chemical. So where would the food that we eat just be changed physically? It's not changing chemically. If we are chewing an apple, it is still an apple. Where would it be? Our teeth grinding. Whenever our teeth are grinding, we're just taking a big piece of apple into smaller pieces of apple, but it is still apple. Okay? In our esophagus, once again, the food just travels down. There is no change here. It's just traveling down. Okay? So once again, kind of think of where would you have physical changes? I gave you two. And where would you have chemical changes? For the most part, chemical changes in the digestive system have to have some sort of chemical in there to help with the digestion process. So in the stomach, I'm going to give you one. That's where you have a chemical change. The food starts to get altered by those stomach acids, and they start to change the food. Okay? So I'm going to go ahead and leave you guys here. If you have any questions, once again, please feel free to contact myself or whoever your science teacher is. And we are more than happy to help you guys. Have a great day. Bye-bye.